This video looks at the concept of specific heat capacity. In order to understand it, you'll want to have some awareness of what a temperature unit is and what our temperature scales are. Let's start with a brief formula and some definitions. Well, really, let's start with the definition. So heat is just a form of energy, and we have two forms of energy that we often reference, heat and light. And specific heat capacity is going to talk about heat and what happens to heat and whether substances really like to hold on to heat or whether they really like to just kind of let it pass through. So to talk about that characteristic, whether a substance really holds on to heat or whether it lets it go really quickly, we use specific heat capacity, which is the amount of heat needed to raise the temperature of 1 gram of substance 1 degree Celsius. And so what you can think about this is let's say I have some type of substance here, and let's say it really likes heat, and heat is often written Q. So it might be that I add lots of Q to this substance, but it really likes it and has a high specific heat capacity, and so the temperature doesn't really go up very much. It goes up a little bit. Versus if I have a substance with a low heat capacity, I can add some heat, and in that case, my temperature goes up a lot. And it also doesn't stick around very long. So this would be a low specific heat capacity. So our formal definition then is shown right here. Heat, which is often written as Q, is equal to the mass of the substance times the specific heat capacity times the change in temperature. There we go. So let's do an example. You have a hot water bottle, and you're using it because you have some sore muscles. And you want to know how much heat energy is actually leaving this water and coming into my sore muscles. So we know that heat equals the mass times the specific heat capacity times the change in temperature of the substance. And I want to know Q because it says how much heat in calories. So there's my question mark. It gives me the mass of water, it gives me my initial temperature, and it gives me my final temperature down here. And then it also gives me the specific heat capacity of water. So it looks like I've got enough information to plug things in for the variables here. So Q is what we want to know. We know the mass, it's 1,500 grams. I know the specific heat capacity, it's 1.00 calories per gram degrees Celsius. That calories, by the way, calories and joules are both units of energy. Now, in chemistry, these heat calories are actually smaller than your food calories. Food calories are actually kilocalories in chemistry. So just keep that in mind. When we say calories, we're not actually talking food calories here, although it's the same idea. It's an energy unit. So I've got calories, and then I need my change in temperature. And in this case, I'm referencing the hot water bottle as the place that I'm starting. So this is going to be my initial temperature, 70 degrees Celsius, and I'm going to subtract 38 degrees Celsius. And so I will plug all this into my calculator, and when I do that, I get, hold on, gotta get my calculator. You can do this too at home. So 1,500 times 1, which will really not be anything exciting, and then times 70 minus, oopsie, calculator's not working, minus 38. And that gives me 48000. Now check your units here. Grams canceled out here, and degrees Celsius canceled out there, so I have calories as my end unit. I also want to check significant figures. I see that 1,500 only had 2 sig figs, so 2 sig figs in my answer, and I'm good to go. If it takes 18.6 calories of heat to raise a temperature of 12.0 grams of a substance by 10 degrees Celsius, what is the specific heat of the substance? Okay, this is looking at the problem in a slightly different manner, where we still have heat, or Q. Let's just be consistent, call heat Q. That will keep things more straightforward. Q equals the mass of my substance times the specific heat of my substance times the change in temperature of my substance. Well, this time I see that I'm given the calories of heat, I'm given the mass of the substance, and I'm given the change in temperature. And then I'm asked to solve for the specific heat. So I'm going to do some algebra against specific heat by itself. So I'm going to divide out the mass and the change in temperature. Those guys will just cross out over here. And so the specific heat will equal the heat divided by the mass times the change in temperature. So my heat was 18.6 calories, and my mass was 12.0 grams, and my change in temperature was 10.0 degrees Celsius. And when we plug that into our calculator, 18.6 divided by 12 and divided by 10 gives me 0.155. That looks good. I have 3 sig figs in my measurement and 3 sig figs in my answer. My units are a little bit more complex this time because nothing cancels out. I have calories divided by grams degrees Celsius, which is our specific heat unit.